So in this video, we're going to apply the chain rule in a context that also involves a radical function. So it says find d dt of h of t. So in other words, find the derivative of h, find dh dt, or h prime of t is what we're being asked to do. And the function is h of t equals the cube root of t squared minus 8t plus 2. So the inside function is the quadratic t squared minus 8t plus 2, and the outer function is the cubing function. So just like the previous video, if we do it with a substitution, we let u equal the innermost function. In this case, we would let u equal t squared minus 8 times t plus 2. And then that would leave us with the cube root function as the outer function. So we would have y equals the cube root function. And inside of the cube root function is the u, because we did the u substitution. And then the derivative is going to require that we know dy du, and du, in this case, it won't be du dx, it'll be du dt. So we want to find dy dt, or dh dt. So I'm going to need to know du dt. So du dt, it's going to be equal to t squared. Apply the general power rule. I get 2t minus a constant multiple times the derivative of t. The derivative of t is 1. So we just get minus 8 times 1 is minus 8. Plus the derivative of a constant is 0, so I don't need to add on the plus 0. So there's my du dt, and here I can calculate my dy du, but this is a radical, so I'm going to want to think of it as being u to the 1/3 power. This is u to the first. The cube root of u to the first is the same as u to the 1/3. So dy du is going to equal, bring the 1/3 down into the coefficient position, times u, and then subtract 1 from the exponent. So we get 1/3 minus 1 is 1/3 minus 3/3 is negative 2/3. And there's our dy du. So to find dy dt, we're not using x this time, we're using t for the input variable. So to find dy dt, that's just going to equal dy du times du dt, which is going to equal dy du sitting right here. It's just 1/3 u to the negative 2/3 times du dt, so times parentheses. So I need to make sure I'm distributing this into the parentheses so that it's being multiplied by both the 2t and the minus 8. So there's that. And then if I want a positive exponent, I could always bring the u to the negative 2/3 down into the denominator position. I think it's your choice. So if you wanted to eliminate that negative sign on the exponent, we could write it as 2t minus 8 over 3 times u to the positive 2/3. That would be okay to do. And then equals, we have to substitute back. We had done a u substitution at the start, and now we'll need to substitute back 3 times u to the 2/3. That's a horrible exponent again, 2/3. And it's still a horrible exponent. And replace the u with the t squared minus 8t plus 2. I have to try one more time. That's so bad. If it doesn't look like it's an exponent, then it's not an exponent. So I could do it without substitution as well. I could think about it more like this. So I've got h of t equaling the cube root of t squared minus 8t plus 2. And then I could rewrite the radical form using a rational exponent. So I can rewrite this as t squared minus 8t plus 2 to the 1/3 power. And then I could work on taking the derivative. And in this case, I want to recognize that the 1/3 power is the outer function, and the t squared minus 8t plus 2 is the inner function. And the chain rule in this formulation says just take the derivative f prime of the outer function. Take the derivative of the outer function. So the derivative of the outer function, which is the 1/3 power, is going to be bring the exponent down into the coefficient position. There's stuff on the inside, don't worry about it for a minute. Bring the 1/3 down using the general power rule. Subtract 1 from 1/3 to get the negative 2/3. And then this says take the inner function and put it inside the derivative of the outer function. So the t squared minus 8t plus 2, that's on the inside of the 1/3 power, comes down, and then times, and then it says take the derivative of the inner function. So now I need to take the derivative of that inner function. So the general power rule says the derivative of t squared is just 2t. Minus 8 times the derivative of t. The derivative of t is 1, so minus 8 times 1 is minus 8. And the derivative of a constant is 0. So there's my derivative. And again, I can leave it with the negative exponent. There's nothing wrong with doing that. Or I can choose to make the exponent positive by bringing this term down into the denominator position. So for this one, I'm going to just leave it like it is.